Hi, I'm John Lockwood, CEO of Algo-Logic Systems, Inc., and I want to give you a quick update on what we've been doing to put algorithms into logic. So first, an update on our key value store. And so the KVS is what we use to share real-time data about stocks, options, and futures over the network that tick at nanosecond timescales. So latency is key. We also use our key value store for throughput, and so that for large graph applications, this can require searching billions of nodes, and so having a key value store system that scales out to handle billions of IOPs is critical. So in data centers, space is always at a premium, and so 1U servers occupy the least amount of space. And FPGA cards fit nicely into these servers. They fit into standard PCIe expansion slots, and by using cards that have networking ports, we can drastically increase the networking throughput of these servers and also radically reduce the latency. And so one of our applications, our key value store, is unique in the sense that it's entirely implemented in FPGA logic. We literally take packets that come in off the wire, we process them through our low latency Ethernet MAC, we extract out the headers and the payloads, we extract out the keys and the values, we send it to the associative lookup engine, we do insert, modifies, and deletes, and we send the results back out to the network by reconstructing a packet and sending them back out the Ethernet MAC, and do all of that in FPGA logic with a latency that's under a millionth of a second, a microsecond. And so putting this together into a system, we start off with a base system, which is a 1U rack server. It's a 2-socket server, and attached to the CPU sockets are standard DDR memory, and a Mezzanine card so that applications that need to talk to the processors over the network go through the NIC. But to turbocharge the system, we installed 3 FPGA cards. And so these are 3 FPGA cards in half-height expansion slots. And on these cards, we run the Algo-Logic key value store gateware. And our gateware runs as logic in the FPGA cards. And then all of these devices are uplinked to a top-of-rack Ethernet switch so that data can come into the server both through the Mezzanine NIC to get to the software system and through the FPGA card directly to get to the key value store running in logic. So then client applications can be written with standard C, C++ APIs and run in a scale-out server. And so they can generate and receive packets that have key value lookups just by sending them over standard Ethernet switches. And so then those packets get forwarded by the switches to either the FPGA cards that directly service the key value lookups for those tables, or to the software system via the Mezzanine NIC. And so some details of the system we implemented was with a Dell EMC PowerEdge R6525 server. This is a 2-socket server, 96-way multi-threaded. It has 3 expansion slots. Those are the slots where we put our FPGA cards in the riser slots. And it also has a Mezzanine slot just under the FPGA cards that's used for the NIC. And so then we uplink all of the traffic out of this with fiber. And so we have 12 fibers coming from the FPGA cards and 2 fibers coming from the dual port Mezzanine NIC. So the key outcome of this was that we're able to hit 490 million IOPs from this rack server. So most of that came from the 3 FPGA cards. So each of those cards is providing 150 million IOPs in the KVS tables. The software complex, the 96 threads on the CPU system, provided an additional 40 million IOPs by running Redis and software. And so combined, we're able to hit 450 million IOPs from FPGA logic, plus 40 million from the software system, 490 million IOPs in the system. So another product that Algo-Logic has completed is an integration of our ultra-low-latency MAC and our TCP endpoint into an FPGA card platform that allows our customers to write their own business logic and send traffic to other nodes in the data center directly from that logic in the FPGA card using our networking stack that runs in logic. And so that logic can be written either in Verilog as RTL, or it can be written in C or C++ and compiled with an HLS compiler into logic that runs on the FPGA card itself. For applications that still run in software on a Xeon processor, is that Intel provided their data mover, which is a kernel bypass system, so that we can send data frames from software applications to the logic with the low latency. So this reference application is available from Intel with the Algo-Logic MAC and the TCP, and runs and has been tested in HP DL380 Gen 10 scalable servers. So in conclusion, we see that FPGAs massively increase networking throughput and lower latency in gateware. Kernel bypass further improves the throughput and latency for software applications. We saw a Dell 1U server with Alveo cards running the Algo-Logic key value store that provided 490 million IOPs. We also saw a reference design running on the PAC card that connects business logic to Algo-Logic sub-microsecond MAC and TCP. So all of Algo-Logic solutions are available today on multiple FPGA cards and servers, or they can be accessed via our secure VPN. So for more information, just visit us at algo-logic.com/KVS. Thank you.